Still continuing with our topic on making a subject of the formula, we shall critically look at some other examples concerning the topic. So we shall look at an example where we have our m equals to n into k squared minus x squared. So here they want us to make x the subject of the formula. So what shall we do? We shall simply first separate this. You remember this is a multiplication, multiplying the whole of this bracket. So what shall I do? I'll have to divide both sides by n, so that I'll have m over n equals to n over n into k squared minus x squared. Here they told us to make x the subject. So this bracket is just signifying that we should make x the subject of the formula. So from there, this n and n go. I remain with m over n equals to, we shall have k squared minus x squared. So since this is having a negative, I can take my x this side. For it to become a positive, then I carry this, I put it the other side. So when x comes here, becomes a positive. Here I remain with my k squared, but this crosses, comes this side, becomes a negative. So the only way to remove a square is putting a square root both sides. So the result is either positive or negative. So k squared minus m over, this is our k squared, m over n. So the square goes with the square root. We shall finally have our x equaling to positive or minus root of k squared minus m over n. So that is done with that. So looking at another example 2, where we're given that our t equals to 2 pi root of x over g. So they want us here to make still a x. So what shall we do? First of all, remove this. How? Dividing it both sides. So you have t divided by 2 pi. Even this side, you get the 2, divide it by the 2 pi. But remember, we still have our root here. So this is our x over g. So this cancels out with that. So we shall have ideally our t over 2 pi equaling to, this cancels out with that, remain with the root of x over g. But for us to remove this square root, we ought to square both sides, so that this square squares the numerator and each of the numbers in the denominator. Square 2, you get 4. Square the pi, you get pi squared. So this will give us the square cancelling out with the square root, remain with x over g. So multiply the g times g times g. The g will cancel out, here remain. So we shall have our t squared g over 4 pi squared equaling to x. We have made simply the x of the subject. How? I've multiplied this side by the g cancelled out. I've multiplied this one by g also to get t squared g. Therefore, our x will equal to t squared g over 4 pi squared. I've made simply x the subject of the formula. We can also simply look at this example, which is not far different from what we have done. So we are given that our s equals to n over 2 into 2a plus 1 minus n minus 1 into d. So for this example, we want us to make n the subject of the formula. So remember, we said what is in a bracket is signifying what we should make the subject of the formula. So since we are making n and I'm seeing 2 n's, so what I will do, first of all, cross multiply. So remember, our s is over 1. So the 2 cross multiplies this side. I have 2s then the 1 also multiply this side. I remain with n into 2a plus n minus 1 into d. So that's what we are having. So I'll just now open this bracket. 2s will equal to 2 times that 2an plus n times this d. We get n d into this bracket. We have not yet opened this bracket, n minus 1. I've only said n times d. I got n d, which is there. So I have my 2s. So this is 2an plus this times this, we get n squared d. So minus still n what? N d. We can also identify that this will end up in the aspect where we have to complete squares. So this is in degree 2. There is an n here and n here, which is all in degree 1. So we can bring these degree 1s together. We factorize out that n. So just leave this one is our constant this side. So I'll begin with my n squared d, then plus 2an minus n d. So here I will ought to factorize out that n, which is common. I pull out the n, I remain with 2a. Here I remain with minus d. So this quadratic equation is in terms of n. Reason being, we have n squared, we have a n, so it is in terms of n. I can easily interchange, and I say what is on my right come on my left, and what is on my left go to my right, which I'm doing here, equals to 2s. So I'll make sure that the coefficient on n squared is 1. How? I divide throughout by that d. So dividing throughout by the d, dividing throughout by this d, I divide throughout by the d, I'll end up with my n squared plus, okay, that is, let me begin with the coefficient, which is this, the whole of this, 2a minus d over d. So this is my coefficient, then I put the n here, equals to 2s over d. So you remember this was a multiplication, it has no problem. Still numerators, only numerators multiply alone. So remember we said when you're completing squares, I've ideally removed the coefficient here so the coefficient is now 1. So this sum, looking at our sum, position of the sum, I get the coefficient, which is this. Here I said we multiply that result by a half. After multiplying it by a half, we shall square the answer we get. We add it both sides. So getting the coefficient on n, which is that, I'll just multiply it by a half. It is 2a minus d over d. I'll multiply the whole of this by a half. I'll be having 1 times the whole of the numerator will be 2a minus d, then over the denominator it will be 2. They don't cancel out this. That will only work if the 2 was also here. So the answer we get, we said we square it, we add it both sides. So this will be n squared. So continue from here. 2a minus d over d into n. You remember we said the answer we add it both sides. What we got, so equals to 2sd, which is this, 2s over d, plus our result, which was 2a minus d over 2d, but this result was square. The result was squared. So looking at the square, looking at this square and this square, I'll maintain n, take the first sign here, then I also maintain 2a minus d over 2d, then I'll just square them at once. This will give me 2 ds over d. Don't expand it, just leave it the up one as it is, plus 2, remember the square will square what is up, I can leave it alone, over what is down. Square 2 you get 4, square d you get d squared. So the LCM here will be 4d squared. 4d squared divided by that, I get a 4d times that, I get 8d. As remember I said is I divided it by the d, the result was 4d. The 4d times the 2s, we get 8ds plus, which is our 2a minus d, all of them squared. So this I can leave it. Remember I want to make n the subject, 2a minus d over 2d, and all of this square. Take the square root on both sides. Remember the result is either positive or negative. So we finally have the square cancelling out the square root. Our n plus 2a minus d over 2d will equal to plus or minus. This will remain the way it is, the upper numerator. I'll just say 8ds plus 2a minus d, but squared, over the square root of 4 is a 2, then d. From there the whole of this has to shift. Remember I am making n the subject, so n equals, this becomes a negative, but put a bracket there because it will affect that. So 2a minus d over 2d plus or minus root of, I can begin with what is squared, 2a minus d squared plus 8ds over 2d. But we said since the denominators are the same, we can also maintain the denominator. We can maintain that denominator. So finally our n will equal to, if you want the negative to enter, it can enter, so that the d becomes positive and this one becomes negative. So I'll begin with what becomes positive. The d becomes positive, the 2a becomes negative, over 2d plus or minus, remember we said the denominator is the same, plus or minus root of 2a minus d squared plus a ds. These are all under root. So that is our final answer. So we shall look at also the last example and see how can we still go about it. So this will be our last example. So if they don't tell you to make the subject of the formula, they can give us a question that says, given that 2g minus e equals to 3g into g minus e. They tell you express g in terms of e, in its simplest form. So in other words, they are telling us to make the subject of the formula, and what are we making the subject of the formula is the g. So what shall we do? So we shall use the same method, procedure. Just come and tell us that our 2g minus e equals to 3g into g minus e, which is okay. So from there, just open this. Remember here we have g also inside g, but you can even see before you open that the g will go to degree 2. This is 3g times that, we got 3g squared. So 3g times that minus 3g e. I've opened that bracket. But look critically. When we look critically, we can ideally see that our g squared, degree 2 g and g. So I'll bring these components together so that I'll leave this side. I've seen that this is already in degree 2 minus, let's remember this one is a positive, okay, minus 3g. Positive come this side where there is another g, the 2g becomes negative 2g. So negative e equals 3g squared. I factorize out the g. When I factorize out the g, I'll factorize out the negative and the g. We remain with 3e, yes, plus our 2. So we can ideally get that. So from there, we shall have to complete squares. So I'll put what is on my right to my left, whatever you want. You can use any alternatives you want, or you can just simply do it from this side. So do whatever you want. I can just take this to my right, 3g squared minus g into 3e plus 2 equals to negative e. So I've just done that, but remember this is power 2, this is power 1. So this is a quadratic equation in terms of g. Reason being g decreased from degree 2, this is in degree 1, and this is degree 0, g power 0. You know that g power 0 is a 1, that's what we don't have a g here. It's just a constant. And here when you're completing squares, make sure that the coefficient on this degree 2, which is our 3 now, has to be removed, should be 1. So divide throughout by that 3. So I divide throughout by the 3, divide by 3, this is this 3e plus 2, divide by 3 equals to negative e, divide by 3. 3 goes, remain with g squared minus g into 3e plus 2 over 3 equals to negative e over 3. Don't make a mistake to cross this out, because it only applies if it can be reduced. If there's also another 3, then it would just be cancelled out. Now from that step, remember this is now the coefficient of the g. This is the position of the sum. So we said we get the coefficient on what this is in terms of g. So we get the coefficient here. What do we do to the coefficient? We said we multiply it by a half, or some other person can say divide by 2, still the same. So multiply it by half. The result will be the numerators alone, the answer will be this, then the denominators multiply them alone. The answer we get, we said we square it and add this both sides. Add it here, add it there. Remain with g squared minus g into 3e plus 2 over 3. I added the result I got, which was a 3e plus 2 over 6 square equals to negative e over 3. I also added the result. Suppose the result is added both sides. So this is what we call completing squares. So looking at this square and this square, I'll maintain the g. Take the first sign always, which is here negative. I've taken the first sign, then take this 3e. I've looked at this square and that square. So take g, take 3e plus 2 over 6, then you square them at once. When you expand this, you'll come back to that, equals to negative e over 3. So when you square this, leave the upper one, don't tamper with it. We leave it as 3e plus 2 squared. But when you square a 6, what do you get? You get a 36. You can simplify that. That can be simplified. So how shall we simplify it? This will be the LCM, which is 36. 36 divided by 3, which is a 12. 36 divided by 3 will be a 12. So when you get that 12, you can continue, because 36 divided by 3 get a 12. This is negative 12e. 36 and that, they will go times 1, 3e plus 2 squared. So this is our g minus 3e plus 2 over 6, all of them square. So get the square root on both sides, so that we eliminate the squared, we remain with g minus 3e. But you remember, this ought to be put in a bracket because of the negative. We can put this in another bracket. So we can put this in another bracket. So we have the square going with that, right? So 3e plus 2 over 6. This sign only affects what is in the numerator, and the square root of the result is either positive or negative. I can decide to begin with a positive first, or what. So I say 3e plus 2 squared. Then I can bring this next minus 12e over, okay, it is over 36, but actually 36 has a perfect square root. That is perfect square root. So make g the subject. How? This one crosses the equal sign and comes here. It becomes now a positive 3e plus 2 over 6 plus or minus. The square root of that cannot be gotten. Leave it the way it is. Leave it the way it is, minus 12e. Then the square root of 36 is a c. Since the denominator is the same, we maintain the denominator. Then what is in the numerator is combined. So 3e plus 2 squared minus 12e. So we have simply made g the subject of the formula. So that's all from the beginning. We have made g the subject of the formula by using the approach of completing squares. So it's not so difficult. Keep on practicing, the more perfect you will become.